So this talk is going to be a little weird, a little different, but Electric Universe, hi Celeste. Uh, Electric Universe claims that the stars don't evolve. Yet, when you look at the stars in different ways, you see that there is a line of evolution. And specifically, Baz, this talk is for you. It's gyrochronology. I remember I told you I wanted to work on it. But the DH ratios and the gyrochronology go hand in hand. But DH ratios they focus on the actual rate at which the hydrogen and the isotopic abundances of hydrogen deuterium change as the star evolves, as well as the other isotopic abundances such as, oxygen 16 to oxygen 17 and 18, as well as the nitrogen, I think 14 and nitrogen 15. The way the abundances of how those isotopes changes as the star evolves, and they lose the lighter isotopes and the heavier isotopes sink down to the center, which gives a good estimate for how old the star is. But unfortunately, I'm looking for data on the DH ratios concerning a lot of the stars that are far away and, have visible spectrums. Luckily, we can look at the star and determine how fast it's spinning, and we can determine its mass. So that being said, when you have its mass, when you have its radius, when you have a arbitrary angular momentum factor in there, such as 0.3, I have the arbitrary angular momentum factor as being 0.3 for all the calculations. And you have how fast it's actually spinning about its axis. You can use that information to determine how old the object is. And this is called gyrochronology. Gyrochronology, meaning gyro meaning spin, chronos meaning age, and ology meaning study. So basically it means spin age study, or determining the ages of objects by how fast they spin. But it isn't just how fast they spin. It's the mass is included, the radius is included, because if you don't include those, you're not going to get an accurate picture, because sometimes older stars spin faster than the younger ones, but the older stars have a lot less mass, so their total angular momentum is going to be a lot less, the total axial angular momentum. And axial angular momentum is when it's spinning like a top. It's axial angular momentum, just like a tire spinning on a car. Not its angular momentum about its orbit. I'm not talking about the orbit. I'm talking about it spinning on like north to south pole. It's spinning like a top. But basically, for those who are new to this, the total axial angular momentum decreases as the star evolves. So it's born, it gains a whole hell of a lot of spin energy from the birthing process. I'm not too sure how that works yet. But that gaining of that spin when it's being formed and it grows and it's being born, that spin is conserved until it gets to a certain stage when it stops spinning up and it starts spinning down again and slowing down and slowing down and slowing down. And this part of the theory, this stellar metamorphosis, I'm trying to work out a graph here, and Baz, I'll send a picture of this graph to you right after I finish this talk. Basically, the purpose of it is to make a single line, and then you can take how much axial angular momentum the object has, and you can determine how old the object is by how much energy it's spinning with. So for instance, I'll start with something that's a little familiar. You guys can actually see this object in the night sky. I'm not too sure when you can see it. I think it's during the summer sky. You can see it in the northern hemisphere. But the Big Dipper. The Big Dipper, that star right there, the very top of the very end of the handle of the Big Dipper, that star, that's Eta Ursae Majoris. Eta Ursae Majoris. I don't know how to pronounce that, let's be honest here. But that star, given its rotational velocity is 150 kilometers a second, which is going really, 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 really fast. Let's just be honest here. And its huge mass, which is 6.1 times the mass of the sun, and its huge radius, which is 3.4 times the radius of the sun, so it's 3.4 times wider than the sun, means that this object is spinning with a whole hell of a lot of axial or angular momentum. And which is kind of cool because the establishment, they have the object as being 10 plus or minus 2.6 million years old. So that star is, they have it as 10 plus or minus 2.6 million. So between 7.4 and 12.6 million years old. Unfortunately, I don't think they're correct on that. That's about the sun's age. The sun's around 6 to 12, 13 million years old. Eta Ursae Majoris is about 100,000 years old. It's about 100 times younger than what they're saying it actually is, which makes more sense because Eta is a blue giant. It's really big, it's really hot, it's really, really, really young. 100,000 years old. And I figured that by taking this graph here, and I have the pink line is the line of best fit. So you have on the, what's that? The y-axis is the age in years, and the x-axis is the angular momentum in the Williams number. So Eta sits about, with Alcyone, I can't pronounce that, Alcyone, but Eta sits a little bit lower than Alcone. I'll just say ice cream cone, whatever. But it sits on that little dot right there. You see that dot and that little X, and then Alcone is right above it. That means that's about 100,000 years old, right on that line right there, that horizontal line. And as the star ages, it moves down that line, down that line, down that line, and then you get to HD 6532. And that star is, let's see, around, what would that be, around 5 million years old. And then you have the sun. The sun sits at about, where is the sun at? Sun sits about 13 million years old. And as it continues on, continues, then you have things like the Teegarden star, you have TRAPPIST-1 over there, you have Beta Pictoris b, and you have then you have brown dwarfs, and you have like things like Luton star and Proxima Centauri are right there, and you have Jupiter, Saturn, Neptune and Uranus, and you have the Earth, Mars, Venus, and Mercury way the hell down there. And you see that as the star evolves, as the star loses its axial angular momentum, we're getting a fax in on a Sunday, it's weird. As the star loses its axial angular momentum, it ages considerably. And both the loss of the axial angular momentum and the rate at which it ages are both, I'm trying to fit them both on this graph right here so we can determine how old these objects actually are. And it's very important because astronomers, for some reason, they still believe that stars are fusion reactors, but they're not. Eta is around 100,000 years old, and they say it's 10 million years old, so they're off by about 100 times its age. Let's see, HD 6532 is around 5.5 million years old, but they're saying it's 2.7 billion years old. And that's really strange because HD 6532 is a F spectrum star. It's hotter and younger than the sun. How can that thing be 2.7 billion years old? That's really strange. The sun is 13 million years old. If HD 6532 was 2.7 billion years old, see, where would it fit on this graph? It would sit about, let's see, age in years, 1 billion, 2 billion. It would sit below Uranus and Neptune. It would sit probably around between Uranus and Neptune, between the Earth and Uranus and Neptune. It'd be sitting right about there, right in that middle. And there's no way. If that star was 2.7 billion years old, it would have nowhere near the mass that it has right now. Stars that are extremely young have enormous masses, and as they age, as they evolve, they lose their mass. But that's lost upon astronomers. They still don't understand the very basics of astronomy, of astrophysics. But even though they claim they do. But I just wanted to make this graph real quick to show you guys what's going on. That was HD 6532. And also the Pleiades. I did Alcone, ice cream cone. But I did some calculations for that, and the establishment, they have it as being 100 million years old. A bright blue giant in the Pleiades cluster, with the Pleiades cluster they say is a 100 million year old cluster. It's not a 100 million year old cluster. There's no freaking way. Those are bright blue stars. Those are very, very young, very, very hot. At most, Alcone, or ice cream cone, is about 70,000 years old, and it's the very top star right about here. You're looking at about a 70,000-year-old star. So when you look at up at the Pleiades cluster, you're looking at stars that maximum are about, or I'd say between 40,000 and 120, 150,000 years old. Those things haven't been around for a very, very long time like they're claiming. 100 million years? There's no way. 100 million years would put that bright blue giant system, the Pleiades, the Seven Sisters, that whole cluster of stars, that would make it a bunch of red dwarfs around a bit younger than the TRAPPIST M dwarf, which is TRAPPIST M dwarf probably around 250 million years old. But about half that age would probably be more around like Teegarden star, but still. The Pleiades system isn't a bunch of red dwarfs. Those are bright blue hot stars that haven't been around for very long at all. But and we know this because they have huge axial angular momentums. If they were around for 100 million years, they wouldn't be spinning with that much energy that they spin with. It's almost as if, like, think about a top. If you spin a top on the ground, or if you have like a quarter. You know how when you spin the quarter, it spins really fast at the beginning, and then it dies down, and then eventually it just flops down and it goes flat on the table? The same thing. What the astronomers are saying is that these objects can spin with their enormous angular momentum and enormous masses, and they're saying it's just like, oh, you can take a quarter and you can spin it, and that quarter is just going to remain spinning forever, for a very, very, very long time. No. If you have something that's that massive and spinning that rapidly, it's going to lose its axial angular momentum, and it's going to lose its mass pretty quickly, relatively speaking, as opposed to the other stars. But yeah, there's that, and I also corrected Beta Pictoris b, which was really easy to correct. But anyways, it's just frustrating seeing a lot of Electric Universe people say that stars don't evolve, when clearly they do evolve. In Electric Universe, they still have the stars as being independent objects. They don't realize that the planets themselves are the ancient evolving stars. They say, well, there's no evidence for stars evolving. You're standing on the evidence. Earth is a 4.5 billion plus year old star. This is what we're standing on, is what a star becomes many billions of years into its evolution. This is a very natural thing here. But Baz, I'll take a picture of this graph. Maybe we can do something on it and give it a name. I don't know. All right, guys, I think I made this video long enough. Later.